acceleration of 9.8 meters per second squared, or 10. If I throw a ball up at 20 meters per second, it'll spend 2 seconds in the air traveling upwards. It'll then reach a point where it hangs in the air, not moving at all. After that, it'll proceed to come back down towards the earth in 2 seconds. It'll hit the ground or hit my hand at the same speed with which it left it, which I think is pretty cool.
Because of gravity, the ball will accelerate downward the same speed as it accelerates upward.
Wait, pause. What's that mean? It means gravity, the same force that decelerates the ball going up, will accelerate it back to its original speed coming down. Because Owen has more mass, it is harder for Addie to move him. Watch again in slow motion. Because Owen's mass is greater, Addison has a harder time changing Owen's state of being and moving him backwards. As you can see, Addison gets somewhat stood up by Owen's large stature. Ethan, however, who is lighter, has less inertia, therefore Addie can move him more easily. In slow motion this time, you can really see Addie connect with Ethan and transfer kinetic energy. And Ethan goes down with a bright smile on his face. Addison is much more able to follow through this time than he did with Owen, because Ethan is lighter. As the baseball rolls through the grass, it will eventually stop. This is because of friction, the force that acts to lessen the forward motion of a body when it is in contact with another substance. Here's how friction works. When surfaces in contact move against each other, the friction between these two surfaces converts kinetic energy into heat. Because Ethan applied a force to our baseball and gave it kinetic energy, it moves forward. As friction transforms the kinetic energy into heat, the baseball slows down and stops. And our data proves it. The ball is rolled towards the lab quest, which means that it will start in the top left-hand side of your screen. And as it gets nearer, the line will go down towards the bottom. The significant aspect of this experiment isn't the line itself. It's the curve in the line. The line proves friction. The ball is decelerating as it moves forward. We know this because this is a distance over time graph. So as it takes more time for the ball to travel the distance that it has been traveling per unit of time already, the line will curve, proving friction. This means that in baseball, if you want to hit a ball farther, swing harder. Or, if you can't change your swing speed and it must stay the same, swing a heavier bat. The increased mass will also make your ball accelerate faster. An impulse is a change in momentum. In the formula, impulse is represented by a j, and that j is equal to force times time. Impulse can be used to decelerate things quickly. The greater force you have in the F times t equation, the smaller t you'll have. So if your force is 10 newtons and your time is 1 second, you'll have 10 newtons per second. And vice versa. What this shows us is that the more time we have, the less force we need to achieve the same result. So the more time you have to stop an object, the less force is needed. This is why baseball players wear gloves. The padding inside the glove greatly lengthens the amount of time in our force times time equation. In fact, in slow motion, you can even see Owen's glove flexing to absorb the impact, lengthening the time, and reducing the force. Now, when the ball contacts bare skin, there isn't much there to lengthen the time. Therefore, the force is much greater. So gloves really do help. They reduce the force to the hand. Without gloves, major league catchers would have broken hands. Listen, you'll hear the painful sound the ball makes when Owen catches it. Baseball is the great American pastime. Anyone who doesn't like baseball is a loser. I know that. Oh, God! Oh, my head. Oh.